Okay, YouTube, in my last video we explored how we could use the process of completing the square in order to rewrite some trinomial on, say, the left-hand side of an equation into a perfect square trinomial so that it does factor down into something squared equaling some constant on the right. And then we could just use square roots to solve that equation. But essentially what we did was we explored trinomials where the a value is actually equal to 1. So one thing I do want to point out is this. We can complete the square always by having some expression x squared plus bx and adding on half the middle term squared to it. If we do this, then it becomes a perfect square binomial, and furthermore it just factors down into the square of a binomial where what we're putting in here is just this b halves squared. The only thing I want to mention in this video is that this only works if the a value is 1. So considering solving this equation here, we're going to do everything that we've done in completing the square up until now, except for what we're going to do is we're going to have to cause this to have an a value 1. We're going to have to modify this. So the instructions here are going to be to solve this equation, and the very first step we always kind of do is we displace this constant term to the other side. So what we're going to end up with here is this 3x squared plus 12x, and this would be equal to, now if I subtracted 15 from both sides, we would have negative 15 on the right hand side. So looking at our pattern up here, if we have an a value of 1, which we do not, then we could add on half this b term squared. So since we don't have that, what I'm going to do is I'm actually going to, in this case we're solving the equation, so I don't mind that I lose this a value. We're going to divide everything by the a value. And so what we end up with here is, well, 3x squared divided by 3 is just x squared. And 12x over 3, well, 12 divided by 3, that's 4x. And then we say the right side, negative 15 divided by 3 is a negative 5. What this does is it kind of transforms it so that now I do have a 1. So if I said, well, what do I really want to add to both sides now that is going to cause this left side to be a perfect square trinomial? Well, it's half of our middle term squared. So half of 4 is 2, and 2 squared is 4. So we're going to add 4 to both sides. And then the left side here is this. We're going to factor it into our perfect square of a binomial where this is half of that middle term that we'll put in here, its value. And then on the right side we get negative 1. So now we're just going to solve this with square roots here. And solving this with square roots this time, I noticed that on the left we just get x plus 2. On the right we actually get the square root of negative 1, which, recalling when we deal with square roots of negative, we'll just put a plus or minus I up front. We say square root of positive 1. Or in other words, the square root of 1 is 1. We just get plus or minus I. So our solutions here, when we subtract 2 from both sides, we're actually going to get two imaginary solutions where it's negative 2 is our real part. We say plus or minus 1i is our imaginary part. And those would be our two complex or imaginary solutions. So I'd like to try this again with the remainder of this video. Go ahead and give these a shot on your own. It would be a good piece of advice I'd have for you. But looking at what we have here, if you're moving forward with me, let's start again. We're going to displace our constant term. So we get 2x squared plus 8x plus some unknown value here is equal to positive 10 plus that same thing. So because I'm solving this, I'm actually going to start by dividing everything by this leading coefficient here, this 2, to make it into a 1. So I would say, well, 2 divided by 2 is, well, that's 1. So we get x squared plus now 8, and this is an x here, I apologize. 8x divided by 2 is 4x plus blank. On the right side we would have 5 plus blank, where we know that half of this middle term squared, well, it'd be 2 squared would be 4. So I'll add 4 to both sides. And in this case here, we know this has to factor into a perfect square of a binomial where, again, we'll put half the middle term in here when it factors. And then over here we get 9. So now we have a square-rooted thing, or sorry, a squared thing equal to a constant. We can use square roots to solve this. So in this case we get x plus 2 equals plus or minus 3, which leads us to, when we subtract 2 from both sides, get two answers here. We get x equals negative 2 plus 3 and negative 2 minus 3. So I'm going to rewrite these separately as negative 2 plus 3 is 1 and negative 2 minus 3 is negative 4. Those would be the x-intercepts of this graph. So we'd say, okay, well, looking at letter B now, I noticed that this is a little bit different. It's not set equal to 0, so our first step of booting that loose term or that constant to the right side has kind of already been done for us. So now, because I don't yet have an a value of 1, I'm going to divide everything here by that leading a value. So we get 3 divided by 3 is just 1, so we really get x squared. And then we would say, okay, well, negative 9 divided by 3 is a negative 3x. And on the right side here, what we get is negative 6 divided by positive 3 is a negative 2. So in this case, it's a little bit different this time. We'd say, well, I'm going to add on half of my middle term squared, and I'll even be explicit on this one. We get negative 3 divided in half squared to both sides, negative 3 halves squared. So in this case, we get x squared minus 3x, and then 3 halves times 3 halves, whether it's negative or positive, will come out to be a positive, and we get 9/4. So in an attempt to go ahead and get a common denominator now, I know I'm adding 9/4 to the right as well. I'm going to change this by multiplying the top and bottom by 4 into negative 8/4 plus our positive 9/4 that you see here. And so the left side, don't get upset by the fact that this is 9/4 here. We say, well, what goes in here is always half of the middle term. So we'd say negative 3, we'll just put it over 2. And on the right side, it looks like we get negative 8 plus a positive 9 is a positive 1/4. So now that we have this square of a binomial, we'll take the square root of both sides. I'm going to borrow some space here. So we get just x minus 3 on the left-hand side. And on the right-hand side, we're going to get plus or minus the square root of 1 over the square root of 4, plus or minus. So we all know that the square root of 1, well, that's 1. We all know the square root of 4 is 2, so we get plus or minus a half. And so now, oops, this is a negative here. Sorry, it's a negative sign, just from right there. We're going to add 3 halves to both sides of this equation. And what we end up with is just as normal, we would say put the 3 halves first, and we say plus or minus a half. So I end up with this, I'd say 3 plus 1 all over 2, which is 4 over 2. And 3 minus 1 all over 2, which is 2 over 2. And we should probably modify these so that they're simplified. We'd say, really, we get 2 and 1 are the two solutions to this equation.